Now that we've reviewed parameters and statistics, I want to give you a little bit of an overview or a framework that's going to guide where we're going for the rest of this chapter. Statistical inference uses sample data and statistics to draw conclusions about the entire population. Because good samples are randomly chosen, if we calculate statistics from these samples, they're called a random variable. So in other words, what they're saying is if I pull a sample of 50 students at random from Western, I calculate their average height, maybe it's 5'7". I pull another random sample of 50 at Western, and maybe their average height is 5'4". I pull another random sample, maybe their average is 5'5". So now I have all of these means from samples from the same population. And so if I take that list of means, now I have a variable and I can start to use a lot of the things that we've been doing in this class on this new random variable. So the first idea here, now that we've turned a statistic into a random variable, we can make a histogram using many samples. So we're taking the mean from each and every single one of those samples, and then we can plot a histogram and describe its properties. Okay, and then that second follow-up question that goes with this is that if we can't actually make this histogram, what sample size is needed for it to be reasonably accurate? Can a relatively small sample size provide results nearly as accurate as a census or asking your entire population? All right, so let's look at an example here. Suppose I went to a local fast food restaurant and ordered their frozen soda drink. If the drink was underfilled the first time I went there, it doesn't necessarily mean that this is an intentional act by the company that they're deliberately shorting me out of my drink. It could be that the machine ran out. Maybe there's a new employee that isn't quite sure what they're doing, and so they filled it lower just to be safe to fit the lid on there. Maybe they were super busy. Right? There could be a lot of reasons why one time that drink was underfilled. But what if I went there every day and I went 50 times in a row and recorded how much frozen drink was actually in my cup? And what if it was underfilled nearly every time? Does that provide better evidence that there's a pattern of systematically underfilling the drink? So, if taking a sample and finding an average will give me more reliable information, how do I get from my skills in chapter 3 of finding the probability for a single event happening in a normal distribution to instead finding the probability of an average occurring in a normal distribution? All right, so suppose those frozen drinks have a normal distribution with an average fill of 20 ounces and a standard deviation of zero point 0.5 ounces. And suppose one of the ones I got only had 19 ounces in it. I can use that Rossman Chance app to find the probability. So my distribution would be n, 20 and zero point 0.5. And then if I put that into Rossman Chance, the probability that I would get a single drink that only has 19 ounces, if it really fills to the 20-ounce line, is 2.5%. So about 1 out of every 45 or so. I would expect to get one that's underfilled. So that's plausible. It's not encouraging that I got the 1 out of 45 that was underfilled, but then that things happen. That's okay. That's life. But the average fill for 50 drinks is also going to be normally distributed, still has an average of 20 ounces, but now that standard deviation is a lot smaller. So now we have a standard deviation of 0.07 ounces. So now if I consider that those 50 drinks average to the 19 ounces as a whole, the probability that I would get 50 drinks that averaged to that 19-ounce underfill, that probability is 0. So now I do have some evidence that something's going on. Either I'm deliberately shorted, there's an issue with the machine, something's going on here because the probability that I would have gotten 50 in a row that averaged to a 1-ounce underfill is 0. All right, come back in the next video and we'll look at how did I get from that standard deviation of 0.5 to 0.07 and what's really going on here.